All right, we're going to do exponential growth. We're going to do section 8.1. We're starting a new unit. Let's get started. All right, we're going to investigate. So I need your graphing calculator out. I'm showing you what an exponential equation is. Notice that there is a number a. There is a multiply in between, and then another number with x as an exponent. This is the first time you've ever seen x as the exponent. We have had x in the past with different numbers as being exponents, but we have never had x being the exponent itself. If you do not put a multiply in between there, like 2 times 3 to the x, you would be 23 to the x. Okay, so you have to put a multiply in between so that it's 2 times that. All right, so let's go on to investigating all these. So I want you to get your calculator out, and I want you to put these two graphs in your calculator. 1/3 times 2 to the x, and 3 times 2 to the x. And I just want you to see what the graphs look like.
So both of them in, or?
Yeah, put like on y1 and y2. We're graphing the 1/3 and the 3 right here. We concluded that this is the 1/3 and that one's the 3, right? Mm-hmm. We concluded that it crossed the y-axis at 1/3 on the one that has the 1/3 in front. And we concluded that we had the 3 there. The question was, do these come sometime go down like that? No. These ones keep going and get closer and closer and closer and closer to 0, but never, ever, ever get there. The reason is because these numbers are negative, correct? These x values are negative back here? Okay, so if I put a negative 2, what's a negative exponent do?
Make it a fraction.
Makes it a fraction. So this makes turns this into 1/4. What happens if I put a really big number like negative 100? It's still a fraction of 2 to the 100th, right? Which is a huge number. But is it 0? It's 1/2 to the 100 power. As this number keeps getting bigger, let's say 1,000. Is that going to be 0?
No.
It's just going to be really, really little. But it never gets to 0. It just gets really, really close. I'm going to give you the vocabulary word for that. We'll talk about that in a minute. You don't have to write it yet, but it's called an asymptote. I'll give you we'll talk about that in a minute, but I'm just telling you now as a little advertisement in a couple minutes. So no, Nariah, these do not come and eventually come down like our cubes that we did a little while ago, all right? They just keep getting nearer and nearer and nearer to that y-axis. So now let's graph the next ones. Let's graph negative 1/5 and negative 5, both of those to the 2x. Do you think it's going to be below the x-axis this time? And what part tells you that, Heidi?
The negative.
The negative. Does our y-intercept still work? So is our y-intercept for this one negative 1/5?
Yes.
Is that this graph here?
Yes.
That's still negative 1/5? Is this one still negative 5?
Yes.
So this crosses the y-axis at negative 5, and it crosses the y-axis on this one at negative 1/5. Okay, so the y-intercept still work. What did the negative do?
I made it decay. Go down.
It made it go down, and this is not called decay. I'll explain what decay is. This is a flipped growth. And so this is growth. Decay means something is going to get smaller and smaller and smaller and smaller, but it doesn't mean it goes negative. The main thing I want you to realize is that all these numbers in the very front are the y-intercept. Okay? All right, let's go like this. So what does that mean over here? Which one's the y-intercept?
What does it change? Oh, sorry.
The letter A.
Yes.
Okay, I think I would write that down on your paper.
I did.
I'd write this thing right here, and I'd just put a little something that says y-intercept. All right, here's some exponential growth. I'm giving you a y equals 2x. We're going to experiment with that so that we can see what happens with other numbers also, all right? So I want us to know what growth is. I would actually write this down if I were you. Growth, it's only growth if that A value is positive. If this value here, and what is the a value in front of this one? What's the a value here?
0.
0 or 1. If I put a 0 right here, and 0 times 2 to the x is going to be, okay, so it's got to be a 1, otherwise we'll have nothing, right? Mm-hmm. Okay, so our a value right now is 1. Is that confirmed? Does that make sense with our graph?
Yes.
It is. It's because, how do you know that?
It's crossing at 1.
It's crossing at 1, right? Okay.
Will you repeat what you said about growth is only growth if?
Growth is only growth if a is positive. If a is negative, it's not called growth. And that's what we saw a minute ago on our experiment. It's also growth if our b value is greater than 1. So it cannot be a fraction. If our b value turns into anything except greater than 1, it is not growth.
Do both rules always have to be true?
Yes.
So if we have a 1/3 to the x as one of our options to pick, that is not growth. So that would not be what we're...
That is correct.
Okay.
All right. Any other questions?
And it's not greater than or equal to. So b can't be 1.
That's correct.
Okay.
If b is 1, you don't have anything. If 1 to the x power, 1 to the first, 1 to the second, 1 to the third, 1 to the fourth, 1 to the
That's true.
fifth, will
It's all the
definitely
same.
not. It'll just be a straight line.
Okay, that makes sense.
All right. All right. We're gonna make a graph. I wanted you to see how we got this graph to begin with. So I'm making a table of values. You can make this table of values if you would like. You don't have to, but I'd like you to plug these numbers in. So on your calculator, you don't have to draw it on your paper. I'm going to start with the 0. I think 0 is always the easiest one to start with.
So you want us to graph this?
You could graph it, or you could just tell me what 2 to the 0 power is. 1. Now I'm going to go down. I'm going to do the 1. 2 to the 1. I put a 1 right in there, and that becomes 2 to the 1 is 2. What's 2 to the 2?
4.
How much?
2 to the 2 is 4.
Yes, 2 to the 2 is 4. All right, notice how they're getting big. They're getting big quite quickly. It went from 1 to 4 in only 2 numbers. What is it going to do next if I went up even higher? 2 to the 3. 8, and then 16, and then 32. These are getting, that's why it's exponential growth. They're getting big faster. Now, what if I change it now to go negative? What if I put a -1 in there? What is it going to do when I put a -1? It's going to be decimals or
0.5.
fractions. It's going to be half. How did I get half out of that if I put a -1 right there? What does the -1 do with exponents?
Makes it a fraction.
Fraction. It flips it upside down, so it'll be 1/2, right? That's why it's 0.5.
Yeah.
What if I put a -2 in there?
It's
Flip it over, and it's 2
yes.
squared, so it'll be 1/4,
1/4.
which is 0.25.
0.25, and then we have 1.125,
which is 1/8. All right.
It's tinier and tinier.
It just gets tinier and tinier and tinier, but it will never get to 0. Okay. So when we are graphing these, I would always start at 0. And the 0 is going to tell you your y-intercept, but you really actually don't really need that one because whatever the number is out there is the 0. We concluded that the number in front and up here was the y-intercept. We did that. You guys figured that out way before I expected you to. You did that on the last slide. Okay. Now we're going to talk about the word asymptote, and I've spelled it for you. The asymptote, in this case, is it x equals 0 or y equals 0?
X equals 0. No. Yeah.
This right here is the asymptote. Is that y equals 0 or x equals 0?
That's x.
It's going through the which axis?
X-axis.
Is this going through the x-axis or is this the x-axis?
That is the x-axis.
Okay, so it's horizontal. Is the y equal lines, are they horizontal, or is it the x equal lines that are horizontal?
Y equals
So this is y equals 0 is the equation of the asymptote. Okay. If I don't move up my graphs up and down in any way, if I don't add numbers to them to shift them around, your asymptote is going to be that y equals 0. All right, I think those two numbers, 0 and 1, are the ones that you'll use the most. If you have, the 0 is quick to find. It's your letter A, always. But the next one is, if I plug a 1 in, this doesn't change. And then it's just these two numbers multiplied. Okay? So if you had y equals 3 times 2 to the x. Excellent. Let's change this because Naya's really wanting me to do something besides different than that too. What's 0 comma what? My y-intercept is 3. And if I plug a 1 in, then you just multiply these two numbers together. 12. Those, they won't ever
just
do
makes the growth steeper.
Yes. It
Like,
just makes the growth
significantly steeper.
Yes. Yeah.
Okay.
Well, this both of them together will make it significantly steeper. Yes.
Okay.
But these two values are going to be your nicest ones. This number right
So
here.
what do you do without your calculator?
And yes, and that's what I'm hoping you, because your calculator just slows you down. So, and you know that the x-axis is your asymptote. So when you graph it, you'll have your 0, 3 and your 1, 12, and then you'll have it going through. Okay?
See where.
What did we conclude? We have concluded that the y-intercept is A. We've concluded that the x-axis is your asymptote of the graph. Now let's do some together. Number 1, and I've been waiting for this for a while. Number 1. All right. So what's my y-intercept on this one? 5. Actually, wait. We're just number 1. This is a multiple choice. So
3.
So
That's
3.
confusing.
So which one is it?
C.
It's got to be C automatically. There's no other one it could be. Answer C for number 1. You with me so far?
Yes, ma'am.
Okay. Has to be that one
Why?
because it's the only one with 3 as the y-intercept.
Oh. Duh.
Okay. Number 3. What's the y-intercept on number 3? 2. All right. So 2, is there any with 2 as the y-intercept? I have 2 possibilities for mine. Do you still have 2 possibilities?
Yeah.
Yes.
Okay. So which is it? A or, so what I do is 1 comma, this will be 1 comma 8, and this will be 1 comma 4. Which is it on my graph?
4.
1 comma 4. So what's the answer have to be?
Yeah.
Yes.
Okay. 1 comma 4. Okay.
Yes.
So remember, to find the 1, all you do is multiply these two numbers together. Because putting a 1 in here one exponent doesn't change the number. And then you can just multiply those two numbers together. All right. So I hope I've helped you to be able to figure out how to do those. Let's do number 9. We're going to sketch this together. I really only need 2 points. I need the y-intercept
5.
and 0, 1, which is 5. In this case, yes. So let's put a 5. And then 1 comma what?
10.
Okay, because we just multiplied those two together, right? So 1 comma, this is going to grow really fast. We know the asymptote, which you don't have to draw, but you need to know where it is. Where did we say the asymptote was?
0.
At this line down here. So that means we're going to start being close to it, and get bigger and bigger and bigger and bigger and bigger. Put an arrow on both ends. We're growing at a fast rate. All right, these can be picked up and moved around. So I could add to the x, and I can add to the whole thing. Remember, adding to just the x part moves it side to side. Just like we've been doing all along, okay? And what does this k do?
Move it up and down.
Moves it up and down, okay? Yep, write that down. I'm going to suggest that you start with the asymptote. The asymptote is going to move up with the k. It's going to be at the 0. If you add 1 to the equation, it's going to move up to. So your asymptote's going to be at the k value always. And your x-axis is going to your x-axis is going to kind of move around in a sense with that h. All right.
Okay.
So
That makes sense.
we're going to graph it like that I'm going to kind of give it a new asymptote. So we're going to do an example.
State the x-axis, the x equals h.
Yes, I will when I do an example.
Okay.
All right, we're going to move up k and move to the right or left h. You can always make a table of values. If you don't like what I'm going to do now, you can always just start plugging numbers in and like I did earlier. Remember that your asymptote is at k. Let's do some together. I'm going to do number 12. All right. Is this number up here moving us? Is that making
Left
our
and
asymptote move or just left and right?
Left and right.
Okay. So my asymptote's still staying down here. Are you with me?
Praise the Lord.
And instead of us having the y-axis being 1, our y-axis is kind of like being
1, 1.
at, is it going to move to the left or to the right?
To the whatever, to the positive. No, to the negative.
To the negative because we do the opposite. So we're kind of like having a new, I'm going to put this in new y-axis. Thank you. New y-axis. All right, so where is our y-axis? Where would have our y-axis been if we hadn't have added that 1 to it?
5.
So we're going to put a 5 on our new y-axis right there.
So we have to draw a new
This is what I'm suggesting.
Then do we draw a new y-axis?
10. Well, this is
Or
not the
Can we just do it on 5 without
you can
the
just
line?
you can
Or
just
on-
you don't
on
have to draw a
negative
new
one?
one if you don't want to. I'm just doing that so you can see it.
Okay, that's helpful.
All right, and then remember I told you to multiply these two together for the one that's next door, right?
So
10. So it would be at 10 there.
Oh, it would be right on the other y-axis.
Yes.
Right there.
And our asymptote's going to stay the same. So there's our new values. If you wanted to just come over here and make an X and a Y and plug 0 and 1 and 2 or something like that, and you plug a 0 into this, 0 right there,
1.
you're going to have a 1. 2 to the 1 is 2 times 5 is 10. All right. Plug a 2 in.
4.
Or 1 in this case, I'm sorry, 1. That's 1 plus 1 is 2. 2 squared is 4. 4 times 5 is 20. You probably couldn't do a 2 after that because it only goes up to 20.
Where are you going to do 4?
Because I'm plugging...
2 times 2. Yeah.
Yeah, 2, because this is 2 to the 2.
I caught on.
Okay,
Can't
good.
say it, but I
So you
caught
could
on.
do that if you don't like the little shift thing that I just did, moving things up and around.
But that gets us something different.
No, it doesn't.
Oh no, it doesn't because we
I
did
still
0
have
to the 10.
I still have 10 and I still have 10 right here,
Yeah,
and I have
follow.
120. Okay.
Oh, so you're just
Right.
plugging in this X number on this chart here into that, and then
Yes.
you're just doing it as a...
Yeah, if you like that. You always can put these in your graphing calculator too. That's not cheating. I want 2 real points, and you can see how it goes. All right. Questions? All right. I think using without your graphing calculator actually makes you go faster. All right. So where is your asymptote for this one? This new one on number 14. By the way, we're on 14. Negative 2. I like putting my asymptote in there, negative 2, because I know that it's going to get really, really close to that one. All right.
When you ask for our asymptote, would you please explain what you mean? Because I'm confused as to where that is when I'm looking
That's
at
the one when I'm going to be graphing it. It comes really, really, really close and then grows.
So just the bottom?
Yes. It's going to be the bottom of your graph. Yes. Okay.
So then would that be 5 up from the asymptote, or would that be 5 on the graph?
So it'll be 5 up from that asymptote. If I plug a 0 right here, that's going to be 1. 5 times 1 minus 2, it's going to be 3. So yes, it's just going to be 5 up from that asymptote. 1, 2, 3, 4, 5. Okay? And then if I multiply those two together,
It's 10.
it's 10. 10 from where?
The asymptote, so is it going to be 8?
Yes. Again, if you want to just start making values, we did 0 and 1. 0 and 1. Plug a 0 in. That's going to be 5 times 1 minus 2. That's 3. That's how we got this number right here. And then we plugged a 1 in. That's going to be 5 times 2 minus 2. That'll be 10 minus 2, which is 8. So if that's easier than what I did, you decide. Okay? Number 6. What's my asymptote looking at the graph? 1. What does that mean for A, B, C, or D? Which one?
C and D it can't be.
Okay, so A and C and D cannot be. Okay, so now, if that's your asymptote, how do we find our answer? So how are we going to decide which is A or B? What do you want to do? I know that it crosses at 17. How does that help us? What X value goes with that? 0. So how does that help us? That's 0, 17. Is there any of those that give us, if is A or B, is one of those give us 0, 17?
Yeah, A, right? Because wouldn't we have 16 plus 1 is 17?
So if I put a 0 right there,
That's 2 squared is 4. 4
4.
times 4 is 16.
This will be
plus 1,
4 times 4 plus 1. Does that gives us how much?
17.
17. This one, if I put a 0 there, that's going to be a negative 1. That'll be half.
Oh, yeah, that won't work.
4 times a half plus 1. That will not give us 17. So we concluded that what was our answer?
A.
A is our answer.
Okay.
Okay.
So she took the second. Oh.
I did that by noticing where the x-axis was. All right, let's use an equation that you've been memorizing. Y equals A, 1 plus or minus r to the t. I am going to define what each of these things are. This is for exponential growth in money, okay? Y is the current amount that you have at the end. Actually, I don't like the word current. I like the end amount is what I like. So it's like end. The end amount. After you put your money in, it's grown with its interest. That's how much you're going to get out. Your end amount. A is your initial amount, or the amount you put in the bank at the very beginning. Or the amount you start with before it grows. If it's positive, it's growth, which we're going to do today. Actually, we'll do some decay today also on these ones. Negative is the decay. R is your percent growth. I'm going to tell you you're going to put it as a decimal. So if it's 7%, you are going to put in 0.07. You will always put in the decimal value for that rate. T is time. That's the last thing. All right, let's do some problems together. Number 16. Letter A.
Oh, wow.
Does this function represent exponential growth or decay?
Growth.
How do you know it's growth?
No negative.
There's no negative. So this is a positive right there. You know it's growth. Okay? So A is growth. What's the initial value in this one? 45. Okay. What is the rate of growth or decay? What percent is it?
5%.
5%. Okay, so we're just kind of going backwards. So we got it right from this would be 1 plus r, and r is right there. And so r will be right there. And we're going to turn it back into a percent. The first year, this is number 20, by the way, number 20. The first year of a charity walk event had an attendance of 500. The attendance increased by 5% each year. Letter A. Write the exponential growth function to represent this situation. So I'm going to have y equals what?
500.
Yes.
In open parentheses.
Mm-hmm.
1
Uh-huh.
plus or minus or plus. Plus?
Mm-hmm.
0.005.
0.00 or just 0.0?
0, because otherwise it would be
0.0.
50.
5.
No, 0.5 is 50%. 0.05 is 5%.
You're right.
And to the t. We don't know what t is at this point for letter A. We're done with letter A.
What? Really?
Yep.
What?
At letter B,
So do you want us to rewrite the fraction and then write the answer? Or rewrite the equation or whatever and then write the answer?
no, what I want
If you
is for letter B, I want you to do this.
Yeah.
In the place of, you can even simplify this if you want, 1.05 if you don't want the plus, if you can do that part in your head.
Is it 250?
And it's going to be 10 there. I don't need anything else. I need this, and then you get your calculator out, type it in. Type it exactly like that. Put the parentheses and everything.
814.4?
814 people.
Yes.
And it
So
says
what's
to
the
the nearest person, so make sure that we don't need that any of those half people today. But we do need a label. 814 people.
Do we have to write that equation on our paper as well?
Yes, I need this equation for A. I need this as your, so I can know what you did, how you got your answer, and then that part. Now we're going to do something called compound interest. You've memorized this formula. That's the cool part. Now let's define what each one of the pieces are. I'll let you get a chance to write that down before I start telling you what each of those are. All right, compound interest tells you how often they multiply that interest into your money. So the bank can calculate your interest once a month. It could do it once a day. It could do it once a year. It could do it a lot and semi-annually, every half year or so forth. And so how more often they calculate your interest into it, the more money you make. Now, when you're making, if you just put $10 into the bank, that interest that it doesn't really, it's not going to matter much if it's annually, semi-annually, quarterly,
Even with
daily.
mine, which
But
is
if you have
hard.
$1 million,
Oh my.
it's going to make a big difference. You're going to want them to compound that interest as often as possible because with $10, there's not as much money. The percentage is small, but with $1 million, there's percentage is high. Okay, so let's just go over each of the things. I'm going to change this again. I don't like the word current amount. It's your end amount. It's the amount you get after it's compounded. The next one is P. This is your initial amount or your principal. It's the same thing as that letter A you had in the other one. The principal is the amount you put in at the beginning. Compound interest does not have a plus or minus. It doesn't have a growth or decay. You only want your money to grow. Okay. The 1 and the plus are going to always be the same. The R is your percentage rate, and it's the same as before. If it gives you 12%, you're going to convert it and put it in as 0.12. You always put the decimal value in there. The N is how often that the bank compounds your money. T is for years.
We don't have N in there.
I will in a minute. Your N is the number of times it's compounded in that year. And I'll give you some examples.
So both of the ends are
The same N, yes,
Okay.
that's correct.
Okay.
So if they compound your money yearly, that means they compound it only one time. All right, so yearly is 1. Semi-annually means it compounded twice a year. Quarterly is 4 times. Monthly is 12. Weekly is 52. These all seem very straightforward, I hope. There's going to be the last one I'm going to give you is going to seem a little strange, and I don't even know why, but daily is going to be 360, not 365.
Because they don't work
5
on
holidays,
Sunday.
they don't count.
Probably because of some holidays that the bankers, I don't know for sure.
Christmas,
New Year's?
Easter. Nothing else seems important enough to not give me money.
Exactly. Exactly. I don't know. Maybe it's a nicer number than. And one thing, if they did that, then they have to get the leap year in there and all this funky things. So, there's
So-
going to be 365.
When you have it,
Actually seems applicable.
Exactly.
Applicable.
This is your. So let's do some. This is like your savings account. All right. So
let's do this.
let's do some. We have. I wanted to know the total value of your investment after the given time. So we have $52,000 at 5.9% compounded semi-annually for 10 years. So I need you to write the equation. A equals, what's P?
The principal initial amount, so that's going to be 52,000.
Very good. 1 plus is just a standard.
Wait. Okay, come that again.
Okay, so this is our principal. I'm using the formula 1 plus, A equals the principal, which is P, $52,000. 1 plus is just standard. Your rate. What goes right there?
0.059.
Careful. Okay, I don't usually put the 0 in front, but you can. 0.59 over N. What's N in this case?
Semi-annually is 2.
Okay. And 2T. You could write the 2 and the 10 here.
Just do 20.
For your calculator way, I would just multiply that out.
But for your notes, I think.
Yeah.
Yeah,
Just so you know why you got that 20.
absolutely.
But in your calculator, I would put that. If you don't put it all together, let's just say you don't know what those two things are multiplied together, you could put them in parentheses, your 2 times 10. You will not, because your calculator knows to divide before it adds.
Okay.
So you do not have to put that in parentheses.
So I got a big old number. I got 93,010.15.
Okay, can you explain how I got that?
That is not what I got.
Okay.
Okay, never mind. Sorry.
93,000, just a second, and this is dollars. 93,010 point how?
15, such another.
Okay. All right. After 10 years, which 10 years for some people to keep their money in the bank's a long time, but you did nothing to that money. You just left it in there, and you got $93,000 now. Almost, not quite double, but close. All right.
Let your money work for you, bitch.
Exactly. That's how people who make large amounts of money can be rich forever if they just don't they leave some of their money in to make money for themselves. They live off the interest of their money.
I was like, what is that noise? The earring's hitting me.
All right, this is what we learned in this one. We learned what? We learned what an exponential growth equation was. We learned how to graph it. We did some application with that exponential growth, and we also did the compound interest. All right? Goodbye.
That is a lot.